When dealing with functions, we often begin with simple things such as a linear function. Other times there might be a quadratic function or perhaps a rational function, and it's important to recognize that functions can be made up of different types of functions combined. For example, we can have something such as f of x equals 3x plus 1 over 5x minus 6. Notice both of these are linear pieces. The top part, 3x plus 1, is linear. And the bottom part, 5x minus 6, is also linear. Being able to identify the various parts of functions can come in extremely handy when we want to simplify or combine functions. In other words, we could define this as h of x, this as g of x, and then we could say that f of x is h of x divided by g of x. Likewise, we can take f of x and break it up into two simpler functions. As an example, let's note an equation such as this below. F of x is equal to x squared plus 6x plus 8. Again, I could define two different functions, such as h of x could be x squared, and g of x could be the linear function 6x plus 8. Then we can define f of x as h of x plus g of x. This new function was formed using two other functions added together. We can use all these basic arithmetic operations such as addition, subtraction, multiplication, and division to create new functions. Here are the notations for the arithmetic combinations of functions. When we are combining h plus g, we're combining the function h of x plus g of x, and it will result in combining like terms. Likewise, the same thing with subtraction and multiplication. Notice with division, we do need to add the restriction that that denominator, g of x in this case, cannot equal 0, because we know that dividing by 0 results in something being undefined. One of the things that you need to be able to do is rewrite functions as arithmetic expressions of simpler functions. And note, there can be more than one right answer. So let's begin with the following examples. Consider f of x is equal to 1 minus 3x plus 16 times the square root of x. There's several ways that we can define these, but if I want to define h of x as 1 minus 3x, notice that takes care of this portion. And then I can define g of x to simply be the 16 plus the square root of x, leaving us with f of x is equal to h of x plus g of x. Likewise, I can define this function as both the top portion, h of x, as simply 3x plus 20, and g of x I can define as 2 plus 13x plus 6x squared, which leaves me with f of x is h of x over g of x. Note, we do not need to restrict g in this case because it can never equal 0 based on the values that we have here. Here is an example of where multiplication is used to define two functions. I can define h of x as perhaps 2x minus 1, and I can define g of x as the square root of x, leaving us with f of x is equal to h of x times g of x. Let's do some examples where we actually perform some of these arithmetic expressions and operations. Here I've defined f of x and g of x. So if I want to add them, I'm going to do x squared plus 6x plus 8 plus g of x. I want to look at like terms resulting in 2x squared plus 6x, and then these like terms result in plus 4. For subtraction, don't forget to pay attention to that negative. We have x squared plus 6x, excuse me, plus 8 minus, we have to add the parentheses, minus x squared minus 4. When we distribute that negative sign, it results in minus x squared plus 4. Note these terms cancel, and we're left with 6x plus 12. With multiplication, you need to make sure that you know how to multiply polynomials. Here we're going to have x squared plus 6x plus 8 times x squared minus 4. We can multiply each term here, resulting in x to the 4th minus 4x squared. We do the same thing with the 6x, which leaves us with plus 6x cubed minus 24x. And last but not least, we do the same thing with 8 plus 8x squared minus 32. And when I combine my like terms, I end up with x to the 4th plus 6x cubed plus 4x squared minus 24x minus 32. Last but not least, I can use factoring when I perform division, and I have x squared plus 6x plus 8 divided by x squared minus 4. When I factor the bottom, it's the difference of squares, which leaves me with x minus 4, x plus 4. And using the AC method or a method of your choice, I can factor the top and get x plus 4 times x minus 2. Notice the x plus 4s cancel, which simplifies. And I'm going to back up here. These should both be x minus 2, not minus 4 and plus 4. So let's fix that. Minus 2 plus 2, which then makes the minus 2's cancel, and I'm left with x plus 4 over x plus 2. Again, we can't let that bottom be 0, so x can neither be 2, since a 2 here would result in 0, nor can x be negative 2.